Welcome back, viewers. Today I want us to look at a different question on longitude and latitudes and the concept of time difference and how you can approach that particular question. Now, in question number 17, we are told that the position of 3 points A, B, and C are A 34 degrees north, 16 degrees west, B 34 degrees north, 24 degrees east, and C 26 degrees south, 16 degrees west, respectively. A. Find the distance in nautical miles between ports A and B to the nearest nautical mile. Roman 2, port A and C, also to the nearest nautical miles. And then in part B, a ship left port A on Monday at 13:30 hours and sailed to port B at 40 knots. Calculate 1. The local time at port B when the ship left port A, and Roman 2. The day and the time the ship arrived at port B. So to get this question right, we are going to make a diagrammatic representation of the relative position of points A, B, and C on the Earth's surface. So we start by drawing a hypothetical globe like that, and we take the equator to be at 0 degrees, and we take this vertical line to represent our meridian, Greenwich, which will also be at 0 degrees. I'm using that because of the dimension. I just want you to see it clearly, so that when we move to the right, we shall move due east. When we move to the left, we shall move due west. Then we have the poles, the northern and the southern pole. So when we move due north, the angles will increase to 90 degrees. Due south, they'll also increase to 90 degrees towards the pole or the southern pole. So A is a point. A is given by 34 degrees north, 16 degrees west. So we draw a hypothetical latitude, 34 degrees north. We mark this 34 degrees north and 16 degrees west. 16 degrees west. We draw another longitude here to represent 16 degrees west. So A is this point here. That is where A is. B is given by 34 degrees north, 24 degrees east. So on the same latitude, but on the longitude it is 24 degrees east. Draw a hypothetical longitude here and mark it 24 degrees east. So this is point B. Point B. C is at 26 degrees south and 16 degrees west. So 26 degrees south, draw a hypothetical latitude, 26 degrees south. This is where we have 26 degrees south, 26 degrees south, and 16 degrees west. So this is point C. So we have the 3 points A, B, and C. Now the first question is to calculate. We're told to find the distance in nautical miles between ports A and B to the nearest nautical mile. One distance in nautical mile. A and B, we have Roman 1, A and B in nautical miles. First, A and B lie on two different sides of the longitude. So we are going to add, or to get the longitude difference, we add the two longitudes. So longitude difference, first of all, we get longitude difference will be given by 16 degrees plus 24 degrees, which is equivalent to 40 degrees. And distance in nautical miles is now given by longitude difference multiplied by 60 multiplied by the cos of the latitude angle. The cos of the latitude angle. Now, so the longitude difference we've seen is given by 40 multiplied by 60 multiplied by the cos of our latitude angle will be given by 34, cos 34 degrees. So when you multiply this using your calculator, multiply that using your calculator, work it out, you're going to get a value of 1989.69, and we are told to give it to the nearest nautical mile. So this will be approximately equal to, when you round off to the nearest nautical mile, 1990 nautical miles. So that is the distance AB in nautical miles. The other part, we're told to find the distance AC, the distance between A and C in nautical miles. A is here, C is here. A and C lie on the same longitude. So that one is easy. The distance between A and C in part 2, the distance between A and C in nautical miles will be given by the latitude difference between A and C multiplied by 60, because they lie on the great circle. So latitude difference multiplied by 60. And what is our latitude difference given by? This is 34 degrees plus 26 degrees. 34 degrees plus 26 degrees. So that gives you 60 multiplied by 60, which gives you 3,600 nautical miles. 3,600 nautical miles. So that is how you answer those two questions in part A. In part B, we are told that a ship left port A on Monday at 13:30 hours and sailed to port B at 40 knots. Calculate the local time at B when the ship left port A. Now, time difference at port A, the time is 13:30 hours, and at port B, at port A, we are told that at port A, the time was 13:30 hours. What would be the time at port B? What would be the time at port B? That is the first question in part A. The local time at port B when the ship left port A. Now we know that the longitude difference between A and B, we've already calculated this. Longitude difference between A and B is given by 16 plus 24, which is equivalent to 40 degrees. And we know that for every 1 degree, a difference of 1 degree between two places that lie on different longitudes, a difference of 1 degree will be equivalent to 4 minutes. Therefore, what about 40 degrees? 40 degrees will be equivalent to 160 minutes. So when you convert this into hours, 160 minutes, you're going to divide by 60, 160 over 60, which gives you 2 2/3 of an hour. 2 2/3 of an hour. And 2 2/3 of an hour is equivalent to 2 hours, 40 minutes. 2 hours, 40 minutes. So, with the concept of time, since we know that the Earth rotates in a west-eastward direction, the Earth rotates in a west-eastward direction, in that direction. If it is 13:30 hours at A, then it means at B they are behind time. Why? Because at A they were the first to see sunrise. They were the first to see sunrise. So at B they saw sunrise only after a duration of 2 hours 40 minutes later. So the time at B now will be given by time at B will be given by 13:30 hours plus 2 hours 40 minutes, or 0 to 40 hours. Let us talk about 0 to 40 hours. So when you add this, you're going to get 0. This will be 70 minutes, carry 1 hour, and then this will remain. We are going to have 10 minutes remaining. Why am I saying 10 minutes? Because when we subtract 60 from 70, we are going to remain with 10. And then we add 1 hour on this other side, we're going to get 16:10 hours. So the time at B will be 16:10 hours, like that. In the next question, we are asked to calculate the day and the time the ship arrived at port B. Now, what day and time did the ship arrive at port B? So you're told that the ship left port A on Monday 13:30 hours and sailed at port B at 40 knots. 40 knots. Now, the speed here that we are dealing with, we should know that 1 knot speed here is given by 1 knot to be equivalent to 1 nautical mile per hour. Like that. 1 knot is 1 nautical mile per hour. So 40 knots mean a speed of 40 nautical miles per hour, like that. The distance between A and B, is given by 1990 nautical miles. So time will be given by distance divided by speed, which is equals to 1990 divided by 40. When you divide 1990 by 40, you're going to get 49 hours and 45 minutes. You can work out that using your calculator. 49 hours and 45 minutes. What does it mean? The ship arrived there. We know that a whole day has got 24 hours. So this is an equivalent of 2 days. It arrived there after 2 days and 1 hour 45 minutes. It arrived at port B after 2 days and 1 hour 45 minutes. So which day are we referring to? On Monday 13:30 hours to Tuesday 13:30 hours. This is a duration of 1 day. Again, on Wednesday from Tuesday 13:30 hours. This is a duration of another day. So we have already cleared 2 days. And what was the time at B? The time at B was now given, or is now given by 16:10 hours, because they're behind time. So to get the time it arrived at B, time at B will be given now by 16:10 plus 1 hour 45 minutes, or 16:10 hours plus 01:45 hours, like that. And the time at B now will be 17:55 hours, and on which day? On a Wednesday. Thank you for watching.